Okay, question 6. During an experiment, a solid is heated from 285 Kelvin to 298 Kelvin. Which of the following gives the rise in temperature in degrees Celsius and the final temperature in degrees Celsius? Now, the rise in temperature, 1 Kelvin is equal to 1 Celsius by magnitude. So, if this rose by a total of 13 Kelvin, the change the change in temperature was 13 Kelvin. That would also be 13 degrees Celsius. So it's either going to be A or B. But what about the final temperature? Now we know the relationship between your Kelvin scale and your temperature scale is this, that your Kelvin scale measured in Kelvin is equal to the Celsius scale plus 273. So if we have got this is our Kelvin scale, so this is the number we're looking at, 298. We're going to have to take it across, and we're going to have to subtract 273 to get our temperature scale, temperature in degrees Celsius. And so that would equal 25 degrees. So that is one over there. So your answer must be B between the two. Okay. Looking at question 7. A liquid is contained in a dish open to the atmosphere. So which of the following contains 3 factors that affect the rate of evaporation of the liquid? Alright, the temperature of the liquid would. Obviously, the hotter the temperature, the greater the kinetic energy of the particles, and therefore more particles will have enough energy, kinetic energy, to break their bonds and escape from the surface. The surface area, the greater the surface area, the greater the evaporation. And the specific latent heat of vaporization, that gives an indication of how easy it is to break the bonds. If that is low, then it's quite easy, and therefore more molecules would be able to break. So that's correct. So it's A is the correct answer. These are wrong because of your mass of your liquid doesn't affect it at all. So mass of the liquid here, these are knocking those all out there. Okay, good. Let's go on to question 8. Question 8. The Kelvin temperature of an ideal gas is a measure of, I hope everybody would get this, it's a measure of the average kinetic energy of the molecules. That's a straight definition. This word measure, it's not equal to, but it is it gives a measure of how great that is. Question 9. The specific latent heat of vaporization of substance is defined as the amount of thermal energy required to. Now the answer for this is D. Change a unit mass of a liquid to vapor at constant temperature. So when when there is a phase change taking place, the temperature remains constant. So I don't know if you remember this diagram here. If we've got the temperature and if we've got perhaps time and we're adding energy, the temperature, maybe starting there, would increase until we get to a phase change, would remain constant temperature, increase again, constant temperature. So this would be perhaps from going from ice, from a solid to a liquid, and this one over here would be going from a liquid to a solid. Then after that it may increase again. So it is D. The answer for 9 is D. Question 10. A gas is contained in a cylinder fitted with a piston as shown below. Right, you understand what a piston is? It's just something that will go up and down a cylinder. Go up and down a cylinder so it can slide up and down that cylinder. This is a cross-sectional area, cross-section picture of that. When the gas is compressed rapidly by the piston, its temperature rises because the molecules of gas are squeezed closer together, B, collide with each other more frequently, C, collide with the walls of the container more frequently, D, gain energy from the moving piston. This is it over here, 10D. Now, the reason for this is that as you move this down rapidly, this is going to hit the molecules, and when it hits the molecules, it's going to exert a force on those molecules, and those molecules are going to be attracted. So perhaps this molecule over here, it hits it, it's going to send in that direction, it's going to accelerate it, the velocity is going to increase, and because temperature is a measure of the average kinetic energy, as soon as the velocity increases, your temperature increases, and that comes from the energy of the piston. The piston will actually be doing work against the gas, so it will be applying a force. So D is correct there. Question 11. It says, temperature is the only property that determines the total internal energy of a substance. That's not true. It determines the kinetic energy component of the internal energy. Remember, the internal energy is made up of both the potential energy and the kinetic energy. The phase state of a substance, that can change according to the pressure. That will change. They can also determine that. The direction of the thermal energy transfer between two bodies in thermal contact. Yes, that will. You'll always go from a higher temperature to a lower temperature. And the process by which a body loses thermal energy to the surroundings, it all depends on the circumstances. Sometimes it can be by convection, conduction, radiation. That can be a number of different ways. But C is correct. Then it says a substance is heated at a constant rate. Now what does that mean? It means that you are adding a uniform amount of energy per second. So your power input is constant. The sketch graph shows the variation with time of the temperature theta of a substance. So in which region or regions of the graph must there be more than one phase of a substance present? Okay, it would be just x to y. Just to x to y would be correct, because here, for instance, this could be water, this could be your ice here, heating it up to 0. Then it starts to melt. So in this region over here, during this region here, you've got the ice melting, so you're going to get ice and water there. Once it's all melted at y, when it's all melted, then this will just be water over here. Okay, so that's 12. And then our final question, 13, for this over here. It says, two ideal gases, X and Y, are contained in a cylinder at constant temperature. The mass of the atoms of X is m and Y is 4m. Which one of the following is correct value of the ratio of the average kinetic energy of Y and the average kinetic energy of X? Well, I hope you'd all go straight for A, and that's 1, because they're at constant temperature, and constant temperature is a measure of the average kinetic energy, and therefore, because they're both at this constant temperature, they are both contained in a cylinder. So both X and Y have got the same temperature. Both will have the same average kinetic energy. What will be different would be the velocity of Y and X. The velocity of X must be greater than the velocity of Y, because your kinetic energy is equal to a half mv squared. So the kinetic energy will be the same, your mass and your velocity will change. But here it's talking about kinetic energy, so both of them are the same.